Hi everyone, here we're going to solve an equation 2 to the power of a plus 4 to the power of b plus 8 to the power of c equals 328, and this is a nice algebraic equation which we can solve if a, b, c are natural numbers. Then find the number of ordered pairs a, b, c. How many ordered pairs you'll have for a, b, c? So for this we're going to start with substituting 4 and 8 as a base of 2. So let's write it down. So in the first step we have 2 to the power of a plus 4 can be written as 2 squared. So we can write it as 2 to the power of 2 whole to the power of b plus we have 8. 8 can be written as 2 cube. So 2 to the power of 3 whole to the power of c equals 328. Now what can be the next step we can do here? As you can see, you have a to the power of m whole to the power of n. So that's equal to a to the power of mn. You multiply the powers. So we have 2 to the power of a plus 2 to the power of 2b plus 2 raised to 3c is equal to 328. Now what can be the next step we can do? As we already know that this a, 2b and this power 3c, now we can take it as some variables, some different variables like p, q and r. Now you should understand where p, q and r are in this. P is lesser than or equal to q is lesser than or equal to r. Now we're not talking about a is equal to p and then 2b is equal to q or 3c is equal to r. No, it should be always p is lesser than or equal to q is lesser than or equal to r. If 2b is smallest, then 2b will be p. If 3c is the smallest, then 3c will be p. And the middle one is q, and if whichever one is the largest one will be r. So that's what we are talking about. So any of them, like 2 to the power of a, 2 to the power of 2b or 2 to the power of 3c will become p. Any of them. So now let's write in terms of p, q and r. So here we have 2 to the power of a can be written as 2 to the power of p plus 2 to the power of 2b can be written as 2 to the power of q plus 2 to the power of 3c is r, which is equal to 328. Now what can we do? What do you think we can do? Let's take out 2 to the power of p outside the brackets. 2 to the power of p outside the brackets, here will be left with 1 plus 2 to the power of q minus p, because we have just added 2 to the power of p here, so we're going to subtract it. And now here also the same thing, 2 to the power of r minus p, which is equal to 328. And then 328 also we can decompose, so that will be equal to 2 to the power of p times 1 plus 2 to the power of q minus p plus 2 to the power of r minus p is equal to, this can be written as 8 times 41. 328 you can write it in terms of 8, and then we are going to convert it into the base of 2. Alright, so now here 2 to the power of p is multiplied, it's a multiple of 2, and 8 can be written as 2 cube. So let's write it down. Now you would be thinking, yes, we are almost there, near to our answer. Let's see, q minus p plus 2 to the power of r minus p is equal to 2 cube times 41. Now you can compare your answers. 2 to the power of p and 2 cube. This is also a multiple of 2. This is also a multiple of 2. So we get 2 to the power of p is equal to 2 cube. So p is equal to 3. So we've got one value for p. Now we can write the same thing. We have 1 plus 2 to the power of q minus p plus 2 to the power of r minus p is equal to, now you can compare it with this one. This whole term with this one is equal to 41. Now let's send 1 this side. 41 minus 1 is 40. So we have 2 to the power of q minus p plus 2 to the power of r minus p is equal to 40. Now what can you do? You can take out 2 to the power of q minus r. 2 to the power of q minus p outside the brackets, and then you're left with 1 plus 2 to the power of r minus p is equal to 40. Now what can you do? 40 can be written as 8 times 5. So we get to write that. So we have 2 to the power of q minus r times 1 plus 2 to the power of r minus q is equal to 40 can be written as 8 times 5. Now you can even again convert 8 into the base of 2. So you're going to write that 2 to the power of q minus, sorry, this is p, q minus p times 1 plus 2 to the power of r minus q is equal to 2 cube, and 5 can be written as 1 plus 4, and 1 plus 4 is 2 squared. Now you can again convert this, you can compare that, this to this. So we have q minus p equals to 3. Alright. Q minus p is equal to 3. And now from this you can say p, we already got it as 3. Since p is equal to 3, we've got p as 3, we can substitute it here. Q minus 3 is equal to 3. So q will be equal to 3 plus 3 equals to 6. So you've got the value of q. Now what can you do next to find the value of r? You have r minus q, 1 plus 2 raised to r minus q. Can you see when you compare this term and this term, doesn't they look similar? Yes, so you can compare r minus q to 2. So let's write it down. We have r minus q is equal to 2. So what is the value of q? We got 6. So r minus 6 is equal to 2. And so r is equal to 8. So you've got p, q and r. But we want a, b, c and the ordered pairs of that. So we have the equation 2 to the power of a plus 2 to the power of b plus 2 to the power of 3c is equal to 328. Now we had substituted p, 2 to the power of p plus 2 to the power of q plus 2 to the power of r is equal to 328. And then that was a condition when p is lesser than or equal to q is lesser than or equal to r. And then we got p is equal to 3, q is equal to 6 and r is equal to 8. Now we have the same thing. Let's write it down. A, then 2b and 3c is equal to p, q and r. This is what we have written. that's equal to 3, 6 and 8. Is that right? Now we have to write the ordered pairs. If you can try to find the values of A, 2B and 3C. Let's just write the values. So you can have A, 2B and 3C. Let's find the values. So if A is 8, suppose if you take A as 8, 2B will be 6 and 3C will be 3. Now 3C, 3 can be a multiple of 3C. Yes. Next, if you take again 3 as a multiple of 3C, and then this can be 8 and this can be 6. Next, you can take 6 as a multiple of 6 is a multiple of 3. So you can write it 3C can be 6. Then 2B can be 8 and A can be 3. But 3C cannot take the value of 8 because it's not a multiple of 3. So we can have only 3 ordered pairs. So ABC are natural numbers. 3C cannot be equal to 8 as I said, because 8 is not a multiple of 3. Now, so we have got the values of A, B and C. So what are the 3 ordered pairs we have got? A is equal to 8, B is equal to 3 and C is equal to 1. If this is 2B, B will be 6 divided by 2, that is 3. This is 3C, C will be 3 divided by 3, that's equal to 1. Next ordered pair, if A is equal to 6, B is equal to 8 divided by 2, that's 4, and C will be 3 divided by 3, again 1. Next, you will have A is equal to 3, then B will be equal to 8 divided by 2, that's 4, and C will be equal to 6 divided by 3, that's equal to 2. So here we get the 3 values of A, B and C. So the ordered pairs, the question was find the number of ordered pairs of A, B, C. That's equal to 3. We have 3 ordered pairs for A, B and C. So thank you for joining, thanks for watching, and thanks for your support always. Keep watching, keep coming, joining, suggesting in the comment box. Thank you so much. Bye bye, take care.